Yes, we can see your screen, so it's perfect.
Okay. Yes. So briefly about me, I'm mostly a dad nowadays. I have 3 kids, so I spend a lot of time home with my children. I'm a computer and system scientist, and anytime I have left outside of work or my children, I will try to involve in football somehow. So I will either watch football or play football. I've been working in IT for more than 12 years. I think I'm reaching 15 years soon. I've been working with open source. I'm a long-time advocate and contributor, and work with Matomo the past 7 years, maybe even more than that. One guy once asked me, what do I don't know? And I replied him, I know a lot about everything. So that's usually my standard go-to when people ask me stuff. But yeah, I am currently working as a freelancer, or I have my own business called George's. I have multiple clients across the world. Some of them are in the States, some of them are in Sweden. I also get requests from different parts around the world. I even got a request as late as today about setting up Matomo in the cloud. So that's what I'm going to talk about also. We will cover some of the benefits deploying your Matomo in the cloud, some of the challenges and best practices for cloud deployments. So some of the benefits for cloud deployments, we have scalability. It's one of the biggest advantages of deploying Matomo in the cloud is scalability. In difference to other traditional setups, especially on-prem, handling sudden spikes in traffic requires substantial infrastructure planning and can lead to underutilized resources. And we have seen this over and over again with Matomo. As we all know, Matomo is a monolithic application. It's not built to be deployed in a cloud environment as microservices, because you get all the services within Matomo is built into one package, sort of. In the cloud, however, resources can be automatically scaled up or down based on demand. And this elasticity means Matomo can easily handle high traffic events without the need for constant manual adjustments, ensuring a smooth experience for end users and more efficient resource allocation. And there's my camera. We have also flexibility. Cloud platforms like AWS, Google Cloud, and Azure makes it easy to deploy and manage Matomo instances. Cloud platforms offer ready-to-use tools for launching, configuring, and maintaining your Matomo servers. You can also quickly set up testing environments, adjust configurations, or deploy new instances to support specific analytic needs. This flexibility allows teams to respond faster to changing requirements, making cloud deployment ideal for dynamic environments. We have cost optimization. Cloud deployments follow a pay-as-you-go model. You probably heard of the term serverless or microservices, as I mentioned. You only pay for the resources that you actually use. So instead of having a designated server for your Matomo installation and for all of the tasks, you can spin up a instance to do one thing and one thing only, and then you terminate that instance to save resources, and ultimately you will save money. So you're doing a lot of cost optimizations in the cloud. Also, many cloud providers offer cost-saving options like spot instances or reserved instances or auto-scaling policies that optimize costs by automatically adjusting resource usage. These options can lead to significant savings compared to a fixed on-prem infrastructure, helping you balance performance and cost effectively. You can also set up a disaster recovery and backups routines in case anything goes down. And if you have pre-built containers, you can just spin up containers. Let's say if you get hacked, for example, you just terminate your resources and you can just spin up new resources on demand. So we can simplify data protection. We have cloud-native backup tools to do rollbacks. You can schedule regular backups or set up a geo redundancy. By redundancy, I mean you can have duplicates of your Matomo in different geolocations around the world, so that you will have more optimized Matomo where in regional spots where it's being utilized. And of course, you can have quick recovery in case of some data outage or data loss. In case we see Matomo utilizing too much resources on one part of your infrastructure, let's say the dashboard, for example, when you have multiple data analysts that will go into your Matomo and do some analytics works, or archiving reports, you can differentiate your trackers into different pods and utilize other caching mechanisms to make sure you save your data in case you have other troubles in other parts of your Matomo infrastructure. Of course, it's not easy to deploy Matomo into the cloud. We have seen this many times. We have done it for huge organizations. We have done it for small organizations. And there will most likely always be challenges. At the time when we started to build Matomo on Kubernetes, Matomo themselves were also figuring out how to deploy Matomo in the cloud. So the documentation there wasn't any documentation, or it was very sparse. So cloud platforms offer scalability and managing performance under heavy traffic, particularly for high demand Matomo environments. As traffic increases, resource limitations such as CPU or memory constraints can lead to latency or slower response times. To handle these demands, carefully planning is required, such as setting up auto-scaling and optimizing configurations for the specific load Matomo will handle. And also monitoring tools play a key role, helping you detect and address performance bottlenecks before they impact the user experience. Other challenges, we have data security and compliance. Data security and compliance are critical in any analytics setup, but they can become more complex in a cloud environment. Cloud deployments means that data protection policies must align with both organizational and cloud provider policies, especially for privacy-sensitive data, ensuring compliance with regulations like GDPR or California Consumer Privacy Act in the States, and requires diligent use of encryption, access controls, and secure storage options that are often built into cloud platforms. Additionally, careful planning is needed for regions with specific data residency requirements, ensuring that data remains protected and compliant wherever it's hosted. We have cost control. Cloud environments operate on a pay-as-you-go model, which I mentioned, which can lead to unexpected cost if resource usage isn't managed effectively. With Matomo, as usage fluctuates, it's easy to over-provision resources to ensure performance, but this can quickly drive up costs. Balancing performance needs with budget constraints means carefully configuring auto-scaling policies and regularly reviewing resource usage and setting up alerts to monitor spending. By active managing costs, you can avoid the common pitfall of cloud cost overruns while still delivering the performance Matomo requires. And complexity of high availability. Setting up high availability for Matomo in the cloud involves ensuring that the system remains operational even if the parts of the infrastructure fails. This typically requires configuring failover strategies, load balancing, and redundancy, often across multiple availability zones or regions. Managing these elements can be complex and require expertise in cloud infrastructure. To minimize the risk of downtime, you'll need to implement load balancers to distribute traffic, set up database replications for reliability, and configure automatic failover. High availability adds complexity, but is essential for organizations relying on continuous data availability from Matomo. The three major cloud platforms, AWS, Google Cloud, and Microsoft Azure, are well suited for hosting Matomo due to their extensive infrastructure, reliability, and flexibility. Each of these platforms offers powerful tools, managed services that simplify deployment, maintenance, and scaling of cloud applications, making them ideal choices for running Matomo. If you think that these providers if none of these providers suits you, you can always be vendor agnostic and choose a different cloud provider, a regional cloud provider where you have your business, and you can set it up with OpenStack or other cloud tools. I have some more to say about AWS. AWS is known for its extensive suite of cloud services, including managed databases, RDS, MySQL, and PostgreSQL. I have clients using Matomo on AWS with Aurora, for example, on AWS, which supports MySQL and PostgreSQL databases. They offer elastic load balancing and powerful auto-scaling capabilities. And AWS auto-scaling dynamically adjusts resources to handle traffic fluctuations for Matomo, while S3 provides scalable and durable storage for Matomo data backups. Additionally, AWS global presence means you can deploy Matomo in multiple regions to improve latency and compliance with regional data requirements. And if you want to use your Matomo in other tools, in AWS, you have Redshift, for example, where you or Zero ETL if you want to build a ETL flow and export your data into other data visualization tools. And we have similar options within GCP, Google Cloud Platform, and Azure. Azure also provides a hybrid cloud, which makes it strong for organizations transitioning from on-prem to cloud environments. So some of the key features that I mentioned are auto-scaling. Each platform offers auto-scaling features, and managed databases, and global regions and compliance, and flexible storage options. Some best practices for high availability is to using load balancers, which is essential for managing traffic across multiple Matomo instances in a cloud environment. Load balancers distribute incoming traffic evenly, ensuring that no single server is overwhelmed and that Matomo remains responsive even during traffic spikes. Most cloud providers like AWS, Google Cloud, and Azure offer managed load balancers that automatically route requests to healthy instances, helping maintain performance and preventing downtime. Database replication enhances data reliability and availability for Matomo, implementing master-slave replication or using managed cloud database with replication like AWS RDS or Google Cloud SQL ensures that data is continually backed up to secondary databases in case the primary database goes down. A replica can quickly take over, minimizing data loss and downtime. This setup provides both redundancy and fallback options, which is crucial for organizations relying on continuous access to analytics. Failover configurations prepare Matomo to handle unexpected server failures by automatically switching to secondary instances when needed. In a cloud environment, you can set up failover for both application servers, and databases to ensure rapid recovery from issues. Cloud providers often support automated failovers as part of their managed services, enabling Matomo to recover quickly from disruptions and maintain availability for end users. Combined with load balancing and replication, failover configurations help create robust, resilient Matomo deployment that minimizes the impact of infrastructure issues. One of the greatest advantages of cloud hosting is elasticity, the ability to scale resources up or down based on demand. Configuring auto-scaling policies for Matomo allows the system to add resources during traffic spikes and reduce them when traffic is low, ensuring optimal performance without wasting resources. This setup prevents server overload during peak times and helps control costs by scaling back when demand decreases. Most cloud providers offer easy-to-configure auto-scaling tools that adapt quickly, keeping Matomo responsive and cost-efficient. Caching is essential for reducing database load and speeding up response time in Matomo. By implementing caching layers like Redis, frequently requested data can be stored temporarily and served directly from the cache, bypassing the database. This reduces the workload on the database and improves overall performance, especially for high-traffic environments where repeated queries are common. Cloud providers often offer managed caching services and makes it easy to add this performance layer to your Matomo deployment. Optimizing database queries is critical for Matomo's performance, especially as the volume of analytics data grows. Indexing frequently queried tables helps reduce response times for common reports for analytics views. In larger deployments, consider sharding or splitting data across multiple databases to distribute the load more effectively. Many cloud platforms offer database optimization tools and query analysis, allowing you to fine-tune Matomo database for maximum efficiency. Using CDN or Content Delivery Network can significantly reduce the load on Matomo servers by caching and serving static assets like images, JavaScript, and CSS files closer to users' geographic locations. This not only offloads work from your main servers, but also improves access speed for users around the world. CDNs help reduce latency, ensure faster experience for global users, and allow Matomo's core service to focus on processing analytics data, resulting in a smoother and more efficient system. Encryption is a fundamental aspect of securing data in the cloud. Using encryption at rest ensures that any data stored within Matomo, whether user information or analytics data, is protected against unauthorized access, even if storage devices are compromised. Encryption in transit protects data as it moves between Matomo servers and users by encrypting it with secure protocols like TLS. Together, these methods protect sensitive data and help compliance requirements such as GDPR. And implementing role-based access control, RBAC, is essential for limiting who can have access to different parts of Matomo's data and settings. By defining roles and permissions, you can restrict access based on each user's role, ensuring that only authorized personnel can view, edit, or manage specific data. Cloud platforms typically provide built-in access management tools to configure RBAC effectively, allowing for granular control over user access, enhancing security and minimizing the risk of unauthorized data exposure. Configuring network security is critical to protect Matomo servers from unauthorized access. Cloud providers offer virtual private clouds and firewalls to create secure network boundaries. By restricting access through VPS, you can limit the network that Matomo infrastructure operates in, isolating it from external threats, firewalls, and other layer of protection by filtering incoming and outgoing traffic, ensuring that only trusted IP addresses and ports can connect to Matomo servers. Regular security audits, and to keep maintaining strong security, it's essential to conduct regular security audits. This involves monitoring and auditing data usage, access logs, and storage to detect any unusual activities, unauthorized access, or compliance gaps. Regular audits help identify vulnerabilities, allowing you to address them proactively and ensure ongoing compliance with industry standards. Many cloud providers offer security audit tools and logging services, making it easier to monitor Matomo security in real time. One of the best ways to manage cloud costs is by right-sizing your resources using only what you need. Regularly monitor Matomo's resource usage and adjust instance sizes to match your current needs. Avoid over-provisioning by scaling down underutilized instances or scaling up only as demand increases. Cloud platforms provide resource monitoring tools that help identify underutilized resources, ensuring you're not paying for more capacity than necessary. Also, many cloud providers offer cost-saving options like spot instances and reserved instances. Spot instances are ideal for short-term or flexible tasks, allowing you to use excess cloud capacity at lower rates. Reserved instances provide discounts when you commit to long-term use, often reducing costs by 30% or more. And by identifying Matomo workloads that are predictable or can be interrupted without affecting critical tasks, you can use these options to significantly lower operational expenses. Automated scheduled backups are crucial for data protection and can also help reduce costs. By automating backups, you avoid the overhead of manual process and can set retention policies that prevent unnecessary storage usage. For example, regularly scheduled daily backups can automatically overwrite older snapshots or move them to long-term storage. This way, you balance data availability and storage costs, optimizing backup costs while keeping data safe and recoverable. And to keep costs under control, set up budget alerts, monitoring expenses in real time. Most cloud providers offer dashboards and alerting tools that allow you to track spending and set budget limits. And by setting up these alerts, you can quickly identify unexpected costs, spikes, or unusual spending patterns. allowing you to respond before they impact your budget significantly. Real-time monitoring and alerts help you stay proactive, ensuring that Matomo cloud deployment remains cost-effective. So let's walk through a hypothetical example of deploying Matomo in a cloud environment to show how we can address scalability, performance, and security challenges effectively. To handle fluctuating traffic, we set up auto-scaling policies on AWS, for example, to adjust the number of Matomo instances based on real-time demand. This configuration allows Matomo to scale up during peak times and scale down during off-peak hours, optimizing resource use and controlling costs. Load balancing and high availability on AWS Elastic Load Balancer, or ELB, distributes traffic across multiple Matomo instances to prevent any one instance from becoming a bottleneck. This setup, paired with database replication on AWS RDS, ensures high availability and reliability. Performance optimization, we can configure a Redis cache layer to reduce database load and improve response time. By caching frequently accessed data, Matomo can handle high traffic more smoothly and deliver faster load times for users. For some of you that already experience with Redis cache layer in Matomo might know that you need to use, or there is a plugin called queue tracking, for example, which will utilize Redis for queue incoming tracking data, which also secures your infrastructure from data loss in case of any other part of your infrastructure goes down. And to protect sensitive data, we implement encryption at rest and in transit use AWS IAM for role-based access control. This is very real-like scenario that I'm working with a client where I am the consultant, for example, and when I need access, I need to use my IAM user to access my client's resources. I can go in and check the logs or monitoring, but I cannot change the actual deployment. So from security perspective, it's a very good thing to use role-based access control. So that setup ensures that only authorized users and systems have access to Matomo's data and servers. We can also configure budget alerts and use reserved instances for predictable workloads to manage costs, automated backups, with a retention policy that balances data availability with storage costs. So this example setup demonstrates how we can use cloud-native tools and best practices to ensure that Matomo operates securely, cost-effective, and with the flexibility needed to meet changing demands. And so some of the key takeaways.
Actually, there is no question in the chat. Maybe we would just wait for a few seconds if somebody have question to ask.
So I can just do a short recap.
Yes, of course. So you still have time if you want to.
No, just for my own sake. Just a short recap of best practices High availability, use load balancing, database replication, and failover configurations to keep Matomo running, even during unexpected issues. Performance optimization, auto-scaling, caching, and optimized database queries. And I know that Matomo has in their docs or documentation, there is a few scripts you can use to analyze your database. Like one is a Perl script and the other one is a Python script, I think, which is called one of them is called MySQL Tuner, I think. The other one I can't remember right now. But those are good tools if you need to figure out your database configuration, if it's set up correctly, or if you want to find other bottlenecks within your database configuration. I'm not sure if they also read the slow query logs or if you need to use a separate tool for that. I don't remember. But those are good ideas to have in mind when you're doing performance optimization.
Okay, thank you so much. There is still no question in the chat, but I know it's still you in the room at 4 p.m. So
Yeah.
if you want, you can stay or leave the stage, but the live stream will be shut down until the next hour. But thank you so much for the first part of your talk, and we'll stay ready for the second part. Thank you.
No worries. Thank you.
Thank you.